Welcome to today's explainer. We're jumping right into a topic that is honestly pure magic when you look at it the right way. Today, we're stepping into a beautifully structured, highly visual world to uncover the hidden patterns that make numbers tick. We're basing our whole journey today on a fantastic source called the Math Adventure with Miss Aya. This isn't your standard dry textbook math, It's a vibrant universe designed to make foundational math concepts really pop. Miss Aya sets the stage perfectly, showing us that math is far from just boring formulas. It's a bright, colorful puzzle just waiting for us to solve it.
And the best part, we aren't heading into this mathematical wilderness alone. Meet Ruggy the robot. Ruggy is our friendly navigator on this learning journey, and he's going to help us decode and process all the cool things we discover. Having a friendly guide really just highlights how accessible and fun these concepts can actually be. So, here is our itinerary for today. First, unlocking multiples. Second, the tale of two buses. Third, what are prime numbers? And finally, decoding factors and composites.
Roji actually maps this whole process out for us as a literal island-hopping journey. We've got to pass through these distinct challenge islands: factors, multiples, prime numbers, composite numbers, and prime factorization to reach that glowing treasure chest at the very end. It totally transforms learning into a real adventure.
All right, Section 1, Unlocking Multiples. Let's kick things off with a rock-solid definition. What exactly is a multiple? Well, simply put, multiples are the numbers we get when we take a base number and multiply it by 1, 2, 3, 4, and so on. In the simplest terms possible, a multiple is literally just the result of multiplying a specific number by any whole number. This perfectly illustrates how numbers scale up just by adding the base number every single time. Take a look at the multiples of 3. We've got 3, 6, 9, 12, 15, 18. Notice a pattern here? The value is increasing by exactly 3 at every step. So if I were to ask you for the next number after 18, you just add 3 and hit 21. It's a perfect, endless chain.
And grouping helps us literally see this math in action. We have Ahmed, Moha, Isha, Asma, and Nosa here, and look at how their beautiful pink roses are grouped together. By organizing things into physical groups, whether it's groups of 3, 5, 8, or 9, we can visually grasp the concept of finding multiples instead of just blindly memorizing numbers on a page.
Let's actually walk through the step-by-step math of this repeating pattern. If we want to find the multiples of 4, we just march right down the line. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. The multiples of 4 are just the answers to those basic equations: 4, 8, 12, 16, 20. It really is that straightforward.
Now, if you want to be a master of multiples, there are 3 absolutely crucial rules you need to lock away. First up, every number has an unlimited amount of multiples. They literally go on forever. Second, the first multiple of any number is always the number itself. So the first multiple of 7 is simply 7. And third, multiples can be greater than the original number, like how the multiples of 6 go up to 12, 18, 24, and beyond.
But here is a super surprising yet essential rule about 0. 0 is a multiple of every single number. No way, right? But think about it. Any number multiplied by 0 equals 0. 8 times 0 is 0. 15 times 0 is 0. It's this universal multiple that completely anchors our entire number system.
Moving on to Section 2, the tale of two buses. We've collected our tools from the first island, so let's check out a real-world application, because these concepts aren't just stuck in textbooks, they're everywhere in our daily lives. Here's a classic scheduling challenge for you to think about. A red bus leaves a station every 15 minutes. A blue bus leaves every 20 minutes. When will both buses leave the station at the exact same time?
We can visually spot the answer to this by simply listing out our multiples. For the red bus, let's list multiples of 15. 15, 30, 45, 60. For the blue bus, multiples of 20. 20, 40, 60. Boom! Right there. They both share the multiple of 60. That means in exactly 60 minutes, both of those buses are going to pull out of the station together. Multiples literally just solved our real-world problem.
Let's hit Section 3. What are prime numbers?
Firing up Raji's jetpack, we arrive at a very exclusive club in the math universe. We need to define prime numbers, and we need to do it clearly. A prime number has exactly 2 factors, no more, no less. Those 2 factors are the number 1 and the number itself.
In other words, a prime number can only be divided evenly by 1 and by itself. That's it. Think of numbers like 2, 3, 5, 7, 11, and 13. They're mathematical loners, but in the best way possible.
To really lock this in, let's juxtapose two different numbers. Is 7 a prime number? Well, its only factors are 1 and 7. Exactly 2 factors? So yes, 7 absolutely makes the prime cut. But what about 12? The factors of 12 are 1, 2, 3, 4, 6, and 12. Since 12 has way more than 2 factors, it is definitely not a prime number.
Which brings us to Section 4, decoding factors and composites. So, if a number isn't prime, what is it? Well, it's a composite number. Composite numbers are the direct counterpart to primes. They are defined simply by having more than 2 factors. Take the number 4, for example. It has the factors 1, 2, and 4. That's 3 factors, making it composite. And our old friend 12, with its 6 different factors, yep, that one is incredibly composite.
But we have to highlight a highly important, totally surprising mathematical fact here. The number 1 is neither prime nor composite. It only has 1 factor, which is itself. It doesn't have the exactly 2 factors required to be prime, and it doesn't have more than 2 to be composite. It is completely unique on our entire math map. As we work with these composite numbers, there's a remarkably handy trick to remember. The factors of a number can always be discovered in neat little pairs. Take 24, for example. You can pair them up. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Finding them in pairs ensures you never accidentally miss one when you're trying to figure out if a huge number is prime or composite. And as a final layer to all of this, let's look at common factors versus prime factors. If we take 28 and 42, their common factors make up a pretty giant list: 1, 2, 7, and 14. But if we distill those down to just their prime factors, the list shrinks. The prime factors of 28 are just 1, 2, and 7. The prime factors of 42 are 1, 2, 3, and 7. We've essentially filtered out all the composite numbers to find the true prime building blocks.
And just like that, we've successfully hopped from factors to multiples, navigated through prime numbers, and explored composite numbers right alongside our trusty guide, Roji. We took a highly structural, deeply visual journey and ultimately unlocked the treasure chest of mathematical understanding. From figuring out tricky bus schedules using multiples to breaking down numbers to their absolute prime essence, you now have a really powerful new set of tools in your mental toolkit. So, I leave you with this. Now that you've unlocked these mathematical secrets alongside Miss Aya and Raji, what real-world treasures, patterns, and puzzles will you discover next? Keep exploring, and I'll catch you on the next explainer.